In today's video, we're diving into one of the most talked about and controversial modern weapons developed by the United States, the AGM-183 ARRW, also known as the Air-Launched Rapid Response Weapon. This system represents America's push into the hypersonic era, where speed, precision, and survivability redefine the battlefield. Hypersonic weapons are changing military strategy worldwide, and the ARRW was designed to ensure that the United States remains competitive in this high-speed arms race. The AGM-183 ARRW is a hypersonic boost glide missile developed primarily by Lockheed Martin for the United States Air Force. Unlike traditional cruise missiles that rely on jet engines to sustain flight, or ballistic missiles that follow predictable parabolic trajectories, the ARRW operates using a boost glide concept. It is first launched from an aircraft, typically a B-52 bomber, and then a rocket booster accelerates it to extreme speeds. After reaching hypersonic velocity, the glide vehicle separates and maneuvers toward its target at speeds exceeding Mach 5, which is more than 5 times the speed of sound. To understand why hypersonic weapons are so significant, we need to understand speed in military terms. Most modern fighter jets operate below Mach 2. Traditional ballistic missiles can travel much faster, but they follow predictable paths, making them somewhat easier to track with advanced missile defense systems. Hypersonic glide vehicles like the ARRW combine both speed and maneuverability. They travel at extreme speeds while also being able to change direction mid-flight, making interception extremely difficult. This is the key advantage: unpredictability combined with velocity. The ARRW is designed to be air-launched, which gives it flexibility and range. When mounted on a strategic bomber such as the B-52, the missile can be carried close to the target area before launch. This increases the effective range of the weapon and reduces warning time for the adversary. Once released, the booster ignites, rapidly accelerating the missile to hypersonic speeds. After the boost phase, the glide vehicle detaches and begins its high-speed descent toward the target, maneuvering along the way to avoid detection and interception. One of the main reasons hypersonic weapons like the ARRW are being developed is to counter advanced air defense systems. Countries such as China and Russia have invested heavily in integrated air defense networks capable of tracking and intercepting conventional missiles. Hypersonic systems aim to penetrate these defenses by overwhelming them with speed and unpredictability. In a high-intensity conflict scenario, the ability to strike critical targets quickly could significantly alter the balance of power. The potential targets for a weapon like the ARRW include heavily defended military installations, air defense batteries, command and control centers, missile launch sites, and other high-value strategic assets. Because of its speed, the time between launch and impact could be dramatically shorter than traditional systems. This reduces the enemy's ability to respond or relocate critical assets. In modern warfare, where reaction time is everything, reducing that window can be decisive. However, developing hypersonic technology has not been simple. The ARRW program has faced several test challenges. Early flight tests encountered issues during the booster phase, where the missile failed to properly separate or ignite as planned. Hypersonic engineering involves extreme heat, pressure, and structural stress. At Mach 5 and above, air friction generates enormous temperatures that can damage materials if they are not specifically designed to withstand such conditions. The thermal protection systems, guidance systems, and structural components all require cutting-edge materials and engineering solutions. Despite these challenges, the program has demonstrated important progress over time. Successful booster tests showed that the missile could achieve the required speeds and separation. Each test provided valuable data to improve reliability and performance. Even when tests failed, engineers gained insights that contribute to future hypersonic systems. This is common in advanced weapons development. Innovation often comes through trial and refinement. Another key aspect of the ARRW is guidance and targeting. At hypersonic speeds, even small calculation errors can result in large deviations from the intended target. The glide vehicle must be equipped with advanced navigation systems capable of functioning under extreme conditions. Electronic components must survive intense heat and vibration while maintaining precise communication and control. The integration of inertial navigation systems, possible satellite guidance, and secure targeting data ensures that the missile remains accurate even at extraordinary velocities. The strategic implications of hypersonic weapons are profound. Traditional deterrence models were built around ballistic missiles and nuclear capabilities. Hypersonic systems introduce a new variable. Because they can strike quickly and with high precision, they blur the line between conventional and strategic weapons. This raises important questions about stability, escalation, and arms control. If a nation detects a hypersonic launch, it may have very little time to determine whether it carries a conventional or nuclear payload, potentially increasing tension in crisis situations. For the United States, the ARRW represented an effort to close what some analysts called a hypersonic gap. Reports of Russian and Chinese hypersonic developments increased pressure on American defense planners to accelerate similar programs. Maintaining technological superiority has long been a central principle of U.S. defense strategy, and hypersonic weapons became a priority area of research and investment. The ARRW also highlights the importance of air power in modern warfare. By being air-launched, it integrates with existing bomber fleets. Aircraft like the B-52 provide flexibility, allowing weapons to be deployed from different regions and recallable before launch if necessary. This flexibility is different from land-based missile systems, which are fixed in location. Air launch capability adds strategic options and adaptability. From a technological standpoint, hypersonic glide vehicles represent a leap forward in aerospace engineering. Designing materials that withstand extreme aerodynamic heating requires advanced composites and heat-resistant coatings. Computational modeling is used extensively to simulate airflow, stress, and performance. Wind tunnel testing and live flight tests validate these models. The ARRW program pushed forward research in propulsion, aerodynamics, and high-speed guidance systems that may influence future aerospace projects beyond military applications. There is also the question of cost and sustainability. Hypersonic weapons are expensive to develop and produce. The advanced materials, precision engineering, and extensive testing contribute to high program costs. Military planners must weigh whether such systems provide enough strategic advantage to justify their expense compared to other weapons systems, such as long-range cruise missiles or stealth aircraft. Public discussion around the ARRW has also included debates about its operational future. At times, reports suggested that the program might be limited or transitioned into other hypersonic initiatives. Defense development is dynamic, and programs often evolve based on testing results, strategic needs, and budget decisions. Even if a specific program changes direction, the knowledge gained feeds into broader hypersonic research and next-generation weapon concepts. In a broader sense, hypersonic technology marks the beginning of a new era in military competition. Just as stealth technology reshaped air combat decades ago, hypersonics could reshape long-range strike doctrine. The ability to reach targets at incredible speeds reduces reaction time and complicates defensive planning. Nations are now racing not only to develop offensive hypersonic weapons but also defensive systems capable of detecting and intercepting them. As we look ahead, the future of hypersonic weapons will depend on continued testing, technological breakthroughs, and strategic considerations. The ARRW was one of the early high-profile efforts in this field, symbolizing America's determination to compete in next-generation warfare. Whether in its original form or through successor programs, the drive for hypersonic capability is unlikely to slow down. In conclusion, the AGM-183 ARRW represents more than just a missile. It represents a shift in how speed and maneuverability can redefine military power. By combining air launch flexibility, boost glide technology, and extreme velocity, it aimed to provide a powerful new tool for rapid global strike. While the program faced challenges and debate, its development underscores the intensity of modern technological competition among major powers. Hypersonic weapons are no longer science fiction, they are becoming a defining feature of 21st-century military strategy. If you found this breakdown informative, make sure to like the video, share it with others interested in military technology, and subscribe for more detailed content about advanced defense systems from around the world.